Welcome to a lesson with Dr. Powell. Let's take a look at an example of finding area that's bounded between curves. So we have one function here and another one here, and we're going to look at the area between these curves, but notice how there's a crossover. Over here, the top function is different than over here. So naturally, if we were to do this, we'd really need to split up into two different integrals, because when we're finding area between curves, we kind of need the top function to stay the top function the whole time and the bottom function to stay the bottom function the whole time, so that when we subtract, we end up getting a positive height throughout the whole thing. If we're interested to know what the actual area is, not a net area, but the actual full area that we visualize. So we'd split it up into two different integrals. So over here on this part, y equals 4 minus x squared is the top function. Then y is equal to x plus 2 is the bottom function. And on this part, we have x plus 2 as the top function, and y is equal to 4 minus x squared is the bottom function. Now, in making this calculation, we would need to determine where the where these two graphs intersect, where these two curves intersect. If we set the y values equal to each other, we could find the common x that would make them equal, simply by setting 4 minus x squared is equal to x plus 2, or just using inspection to realize that x equals 1 works. Or we could make a quadratic and by putting these on one side and factoring, or other means of solving quadratics, and we'd be able to determine that. So this is how you would compute the area. Just remember, you switch. If you switch top to bottom, you need to generate two different integrals representing each case. Thanks for watching.